Hi, Mr. Wright here, and welcome to this video walkthrough of November 2023, Paper 2H. In the description of this film, you'll find a link which will let you download the question paper so you can tackle the questions before you watch this film. Or, of course, if you'd rather work alongside me, you can download the questions and then be working on your copy of the exam whilst I work my way through each of the questions. Also in the description, you'll find links to different parts of this film. So if you don't want to watch every question, you only want to watch a couple, you can move straight to those parts of the film that you want to use. And lastly, you will find a link to a short film at the end where I talk you through the grade boundaries for November 2023, so you can see how you would have done if you were sitting your Edexcel IGCSE Maths for real in November 2023. If you find this film useful, please do hit like. If you've got any questions you'd like to ask, you'd like me to explain anything, or if anything doesn't make sense to you, please leave a question in the comments, and of course I'll respond. Or just take a moment to leave me a comment. Tell me how you found the film, tell me when you're taking your exam, and tell me what grade you're aiming for. It would be great to hear from you. Right, I think that's it. Let's get on with the maths. Question 1. The table shows information about the lengths in minutes of 50 phone calls. Take a moment, make sure you understand what the table is meaning. So I've got length of telephone calls here. So some of the phone calls took between 0 and 5 minutes. 8 phone calls took that length of time. 4 phone calls took between 15 and 20 minutes. So once you've understood what the table means, then you can go ahead and look at the questions. Write down the modal class, the most common class. Well, the class with the most number of phone calls is this one, isn't it? Because it has 18 phone calls. So the modal class is with a phone call between 25 and 30. Now, an estimate for the total length in minutes of these phone calls. Well, I've got 8 phone calls here. Now, how long did each of those phone calls take? Well, I'm going to use the midpoint. So I'm going to assume that each of those 8 phone calls took 2.5 minutes. And each of these, 7.5. And each of these, 12.5. And each of these, 17.5. And each of these, 22.5. And each of these, 27.5. So now to work out my total length of all the phone calls, I've got 8 times 2.5. Well, that's 20 minutes of calls there. 2 times 7.5, 15 minutes there. 12.5 times 6 gives me 75 minutes. 4 times 17.5 gives me 70 minutes. 12 times 22.5, 270 minutes. And 18 calls, each one lasting 27.5, 495 minutes. So to work out the total length of all the phone calls, I'm going to add up those numbers there, which is going to give me an answer of 945 minutes. 945. And that is question 1 finished. Question 2. The diagram shows triangle ABC and triangle ECD. Now I'm looking at right-angled triangles here, so I'm thinking Pythagoras or SOHCAHTOA. Let's have a look. Now I've given lots of information here. AB is 10, well that's marked on the diagram. AC is 8, that's marked. EB is 5. Now careful, that's just that bit, isn't it? EB. EB is 5. CD is 14, yes, that's marked, and ED is W, yes, that's marked. Work out the value of W, give your answer correct to 1 decimal place. Right, well, I suppose I've got a right angle triangle here, and I've got the 14, and the W is the hypotenuse, so if only I knew all of this length here. I know part of it's 5, but what about the other part? What about this part? Well, just a moment. I can use the triangle on the left, this triangle here, to find that part. That's 8, that's 10. So this is BC, isn't it? This bit here is from B to C. So BC will be the square root of 10 squared minus 8 squared. Put that into my calculator, and BC is 6. Okay, so that means now I know that this bit's 6, so the whole of E to C is 11. So now I can be looking at the right-hand triangle. I've got E down to C, which is 11. Along to there is 14. And W is the hypotenuse there, isn't it? So W is going to be the square root of, and this time I'm going to add the squares of those side lengths, because this time I'm finding the hypotenuse. So W is the square root of 11 squared plus 14 squared. Well, on my calculator, I get 17.8044 and so on, and I need to give it to one decimal place, so my answer is 17.8. And that is question 2 finished. Question 3. Reflect the shape T in the line y equals x. Well, the first thing we better do is draw the line y equals x. Draw that mirror line. So here we go. There it is. Now I've got to reflect the shape T in this mirror line here. Right. So it's a diagonal mirror line. So either you can think, right, I've got to count diagonally to the mirror line. So this point would be one diagonal. And so one diagonal the other side, and would end up here. Or you might be used to thinking, if I count horizontally to the mirror line, I have to count vertically from the mirror line. But either way, you can work out where all the points will go. I'm going to stick to my green method. So that point's there, right? This point, half a diagonal and another half a diagonal brings me to here. So there's that line. And then a whole diagonal from here. There we go. I'm getting how it's working now, I think. This point, half a diagonal, goes to here. Look at that. And at some point, you'll find that you can draw the rest of the shape. And there it is. Shape T reflected in the line y equals x. Right, next part of the question. Describe fully the single transformation that maps A onto B. Well, it's obviously going to be an enlargement. Okay, now I need to give 2 more pieces of information. I need to say what the scale factor is, and I need to say where the centre of enlargement is. Now, to work out the scale factor, let's look at 2 corresponding sides. The base is 2 on A, and on B, the base is 6. So the sides have been trebled in length. So the scale factor is 3. Now, what about the centre of enlargement? Well, to find the centre of enlargement, I'm going to join up the corresponding vertices, the corresponding corners, and see where these ray lines would cross. I think I can already see where they're going to cross, but I'll just draw this ray line to make sure. And there we are. They're going to cross here, aren't they? There they are. So the centre of enlargement is going to be 7,2. And there we go. That is question 3 done. Question 4. All right, I need to solve this equation. Well, the first thing I'm going to do is multiply both sides by 6 to get rid of that divided by 6 on the left, to get rid of the 6 on the bottom. So if I multiply both sides by 6, then I'm going to have 2x plus 5 divided by 6 times by 6, 2x plus 5 equals 6 times the right-hand side, 12x minus 30. Make sure you multiply the whole right-hand side by 6. Now, this is an equation with x's on both sides. So let's see which side has the fewest and get rid of them. Well, only 2x on the left. How do I get rid of 2x's? I minus 2x's from both sides. It's going to leave me with 5 on the left and 10x plus 30 on the right. Sorry, 10x minus 30 on the right. Okay, let's add 30 to both sides. Get those x's on their own. That'll give me 35. 35 equals 10x. Divide both sides by 10. X equals 3.5. Okay. Just the laws of indices here. 15, h to the power of 15 divided by h cubed is going to be h to the power of 15 minus 3, isn't it? Subtract those indices. H to the power of 12. Simplify fully. Something to the power of 4. Well, that's going to be 2 to the power of 4. And then g to the power of 3 raised to the power of 4. And k to the 5 raised to the power of 4. Well, 2 to the power of 4, 2 times 2 times 2 times 2 is 16. Right, now, rules of indices again. G cubed raised to the power of 4, you multiply those powers. G to the 12, and k to the power of 5 times 4 is 20. Part D. We've got y to the power of 5 times by y to the power of n. Well, that's y to the power of 5 plus n, isn't it, on the top? And then we've got to divide that by y to the power of 7. Well, that's going to give us y to the power of 5 plus n minus 7. That's supposed to equal y to the 12. What would n have to be there? What would n have to be so that this whole thing equals 12? The answer is that n would have to be 14. So n is equal to 14. And that is question 4 complete. Question 5, we're baking a cake. Now, we've got the weight of flour. The ratio of the weight of flour to the weight of butter is 6 to 5. And then we've got the weight of butter and the rate of sugar, and that's in the ratio 3 to 2. Now, we know that Avril uses 120 grams of sugar. So we can write 120 under here. But we want to work out the weight of flour she uses. Wait a moment. If I use the red ratio, then I can work out if she uses 120 grams of sugar. I can work out how much butter she uses. And then I could put that amount of butter into here to work out how much flour it is. Let's try that. So the red ratio, butter, sugar, 3 to 2, and she uses 120 grams of sugar. So this one has been multiplied by 60, 120 divided by 2. So 3 times by 60 is 180. She must have used 180 grams of butter. So now I can take this 180 and put it here because I know how much butter she uses. Right, 180 divided by 5. That one's been multiplied by 36. So I can do 6 times 36 to work out that she uses 216 grams of flour. And that's number 5 done. Question number 6. Right, show that. So I'm going to ignore this answer, and I'm going to take the question I'm given on the left, and I'm going to work out the answer to that division, and then at the end I'm going to hope that I get 1 2/7. Right, let's turn both of these into improper fractions. 3 times 7 is 21 plus the 3, 24 over 7, divided by 2 3s is 6, plus the 2 is 8 over 3. This is division, so I'm going to keep, change, flip. And now I've got top times top and bottom times bottom. Yes, you can cancel, but I'm going to ignore that. And I'm just going to go 24 times 3, 72, over 7 8s are 56. And then I'm going to take 72 over 56, 72 divided by 56, put it in my calculator, and I get the answer 7 over 9, which Sorry, 9 over 7, which is 1 2/7. And now I look back at the question and look at that. I have shown that it equals 1 2/7. Good, that's question 6 finished. Question number 7, Hermione buys a boat for $26,800. The boat depreciates by 8% each year. Wait a minute, if it depreciates, it goes down. If it goes down by 8% each year, then the multiplier is 0.92 because you've got 92% of it left if you knock off 8% of it. The boat depreciates by 8% each year. Work out the value of it. Oh, at the end of 3 years. So this is compound, isn't it? Compound, so it's the power of 3. So all I need to do is to put that in my calculator. And it says give my answer to the nearest dollar. Now, when I put that in my calculator, I get that. And so to the nearest dollar, I'm going to give the answer $20,869. That is number 7 sorted. Question number 8. The mean number of goals scored by a hockey team in 8 matches is 6. Just a minute. This is all about knowing that you can work out the total number of goals scored, isn't it? Because the total in those 8 matches is 8 times 6. They scored a total of 48 goals in those 8 matches. The team plays 2 more matches and scores K goals in each match. So now they must have played 10 matches, mustn't they? Look at this. The total in those 10 matches. Well, I know there are 10 matches, and I know the mean number of goals scored by the hockey team in the 10 matches is 7. So the total is going to be 10 times 70. Okay, so sorry, 10 times 7, so that's 70. So they scored 48 goals in the 8 matches, and then they had 2 more matches, and now they've got 70 goals. So how many goals did they score in those 2 matches? Well, 70 minus 48, right? What's that? So they must have scored 22 goals in the 2 matches. Okay, now work out the value of K. Well, K was the number of goals they scored in each match, wasn't it? So K must be 11 because in those 2 extra matches they scored 22 goals. So they must have scored 11 goals in each of the matches. And that's number 8 done. Question number 9. A straight line passes through the points with those coordinates. Find the equation of a line. Right, if in doubt, sketch it out. So I'm going to draw a sketch. Now there's my coordinates. Now my straight line goes through the point 0, minus 3. Right, well that is going to be about here, isn't it? That's minus 3. That's the point 0, minus 3. It also goes through 2, 0. It's going to be here, 2 along and 0 up. That's my x-axis. So here is my line, right? It looks like this, doesn't it? Okay, got to find the equation of that line. Well, I wonder if I can find its gradient first of all. Let's have a look. Change in y over change in x. Well, it goes up 3 there, doesn't it? So the gradient, which we often call m, is the change in y, 3 over the change in x, 2. So the gradient's 3 over 2, 1.5. Now, what's the y-intercept? Look at that, I can see. The y-intercept is minus 3, isn't it? So my equation is y equals mx plus c, 1.5x plus minus 3, or better still, 1.5x minus 3. And that's question 9. Question 10. Right, we've got a hexagon here, and we're told various lengths. Let's just check that each of those are labelled on the diagram, and they are. Now we're told the area of the hexagon is 258, and we have to work out the value of x. So what we're going to need to do is we're going to need to come up with an expression in terms of x for the area, and that's going to equal 258. And then we can solve that equation to find x. So how would we find the area of this shape? normally? Well, one thing we could do, I guess, is we could cut it off here. Then we could find the area of the rectangle on the left and the area of the trapezium on the right. Add them together, and that would be the area of the whole shape, wouldn't it? Let's start with this rectangle here. What's the area of that rectangle? Well, it's 25 high, so height is 25 times the width is x plus 2, isn't it? So that's going to be 25 times x plus 2. That's the area of that rectangle. Now, what about the area of that trapezium? Well, I know, what do I know? Let's get rid of this red to help me. Let's zoom in a bit. Now, I know that this length is 7. That's one of the parallel sides. Now, what about this length here? Well, I know this bit's 8, and the whole thing's 25. So that length there must be 17. Right, so now my trapezium looks like this. It's got a long length of 17 there. Comes up here. That's 7. There you go. Now I need to know, I've got the two parallel sides, I need to know its height. So I need to know this length here. How am I going to work that out? Well, this is x plus 2. And this whole thing is x plus 6. That's 4 more, isn't it? So that must be 4. So that's 4. So the area of that trapezium is going to be, and remember the formula of the area of the trapezium is on the front of the, at the top of the paper in the formula sheet if you want it. But that trapezium is going to be 7 plus 17 divided by 2, the average of those lengths, multiplied by the height of 4. Now that is what is going to equal 258. So now I just need to solve this equation. Well, that's going to be 25x plus 50, multiplying out that bracket, plus 7 plus 17, well, that's 24. Okay, so that's 24 over 2, which is 12. 12 times 4, 48. And of course, if you wanted to, you could just put that whole thing in your calculator. And that's going to equal 258. Right, let's tidy up the left-hand side. 25x plus 50 and 48 is 98, equals 258. Subtract 98 from both sides, and 25x equals 160. Divide both sides by 25, and x is 6.4. And it asked me to work out the value of x, and that's what I've done. So that question was all about finding an expression for the area in terms of x and setting that equal to 258 because you were told the area was equal to 258. Okay, that's question 10 done. Question 11. Sid has 2 boxes of crayons, box X and box Y. Right, 5 of the 16 crayons in box X are red, and then 7 of the 20 crayons in box Y are red. Sid takes at random 1 crayon from box X, right, box X, and 1 crayon from box Y. Oh, I see, right, so here we are, we're at the start, right, got to take 1 from box X. Now it's 5/16 is red, because 5 out of 16 are red, so it must be 11/16 that it's not red. Right, so now we get to here. We've taken 1 from box X. Now in this case, that was red. And then we walk up to box Y. Now what's the probability of one of those, that when we take 1 from box Y, what's the probability that that's going to be red? Well, 7 out of 20. So that means that it must be 13 out of 20. That must be the probability that it's not red. And similarly, of course, if we took a not red from box X, and then we walk up to box Y, well, it's still going to be 7 out of 20 probability it's red, and 13 out of 20 probability it's not red. So that's my probability tree diagram complete. Work out the probability that Sid takes 2 crayons that are red or 2 crayons that are not red. So it wants to know the probability that he takes red, well, that's this outcome, isn't it? Or both of them are not red followed by not red. That's that outcome. So I'm going to work out the probability of this outcome, probability of that outcome, and add them together. Now, how do I work out the probability of that outcome? Well, you multiply, don't you? 5/16 multiplied by 7/20. That's going to be the outcome. That's the probability of getting red, and then onto that I'm going to add the probability of this outcome. 11/16 times 13/20. Now the rest of it is just calculator use. And with luck you get the answer 178/320, which you can cancel. So I'm going to put that in my calculator, 178 divided by 320, and that cancels to 89 out of 160, which would be a better answer. However, in this instance, the mark scheme doesn't insist on you cancelling. Okay, that's question 11 done. Question 12. Right, I've got an equation here. I must find x. Now what I'm going to do is I'm going to rewrite this equation here, but I'm going to write everything as base 2. Everything is 2 to the power of something. So that's already 2 to the power of 7. Now 4 to the 5, that's 2 squared to the power of 5. And 4 to the x, that's 2 squared to the power of x. Now I'm going to use my rules of indices to simplify this further, because 2 squared raised to the power of 5 is 2 to the power of 10. 2 times 5. And similarly, 2 squared raised to the power of x is 2 to the power of 2x. 2 times x. So on the left, if I add those indices, I get 2 to the power of 17 equals 2 to the power of 2x. So that means that 2x must equal 17 and x must be 8.5. Okay, 12b. Simplify fully. So this is something to the power of 2/3. So it's going to be each of those written to the power of 2/3. Y to the power of 24 to the power of 2/3. Now I can use my calculator to work out 125 to the power of 2/3. Or you can know it's a cube root squared. So that's going to be 25. P to the 6 to the power of 2/3. We'll use the rules of indices. That's going to be p to the power of 6 times 2/3, which is 4. You could use your calculator if you wanted to. And y to the power of 24 raised to the power of 2/3. That's going to be y to the power of 24 times 2/3, which is 16. So there is my answer for part B. That is my 4 marks on question 12. Question 13. Robert asked 11 people how many meetings they attended last week. Here are the results in numerical order. Find the interquartile range. Right. Now, whenever I find the interquartile range, I always start by finding the median. Now, there are 11 people, so the halfway one is going to be the 6th. But if you weren't sure about that, you can circle the one you think it is and count how many are there this side and how many are there this side. And there are 5 on each side of the 8. So 8 is the middle one. Right, now I want the interquartile range. So I take this first half, okay, and I find the middle one. And then I take this second half and I find the middle one. So the interquartile range is the difference between those two. It's like the range, but you don't take it right from either end. You take it from the middle of the first half and the middle of the second half. So the interquartile range is 13 minus 4, which is 9. Question 14. Here is the graph of the equation 2y plus x equals 1. So there we are. That's 2y plus x equals 1. Okay. By drawing another straight line on the grid, solve the simultaneous equations. Well, I've already got this second one. So really, this question is just asking me to draw this line and then see where the two lines cross. Now that line is y minus x minus 2 equals 0. Now, if I'm going to plot it easily, I think I'm going to write it as y equals. So I'm going to add x and add 2 to both sides, because now I can read off the gradient, which is 1, and the y-intercept, which is 2. So I know it's going to cross the y-axis at 2, and I know it has a gradient of 1. Now, be careful with your scales, but actually this time there's no issue with the scales. So I'm going to go along 1 and up 1, along 1 and up 1, and so on. So there is the line which they've asked me to draw. And now I can read off the answer to the simultaneous equations, as that is where the two lines cross. Because where the two lines cross, that is the point which is on both of the equations. So here's the point where they both cross, and that has x equals -1 and y equals 1. And there is my answer to question 14. Question 15. Use algebra to show that recurring decimal is equal to 41 over 110. Right, well, I'm going to ignore what they say that it's equal to, ignore that, and simply start by saying x equals, now leave a gap here, 0.3. Now I find it useful now to write out a few more digits so I get it in my head what that recurring decimal means. In this case, the 7 and the 2 are being repeated. Now, underneath that, I'm going to find 100x. Now, why have I chosen to use 100x rather than 10x or 1000x? Well, the reason for that will become clear in a moment. If x is 0.372727, then 100x is 37.2727. And you'll notice that the 2's and the 7's have all lined up. Now, if they hadn't, then I would try again and multiply by 10 or by 1,000 perhaps. Now, the reason why it's great that they're all lined up is that now I can do 100x, my second line, subtract x. On the left-hand side, I'll get 99x. Here it is. That's 100x minus x. On the right-hand side, I'm going to do 37.27 minus that. Now, if I were to draw a line here, you can see that they'll all knock each other away. So I'm left with 37.2, subtract 0.3. Well, I could use my calculator if I wanted to. That's going to be 36.9. So 99x equals 36.9. So let's divide both sides by 99. X is 36.9 divided by 99. Now, that's not quite what they want. Look, they want that, don't they? Well, let's start by multiplying top and bottom by 10 to get rid of that decimal on the top. So now I've got 369 over 990. And now, if you were to put that into your calculator and press equals, you will get the answer 41 over 110. Because all I've done there, or all your calculator has done, is to divide the top and the bottom by 9. So there's my answer to 15a. I have shown that that recurring decimal is equal to 41 110ths. Right, simplifying these surds. Now, let's have a look at each of these in detail and work out what they are. The square root of 125. Now, you've got to show you're working clearly. So, yes, you can put the square root of 125 in your calculator, and it will instantly tell you that it's equal to 5 root 5. But let's show those steps. So, the square root of 125 is equal to the square root of 25 times 5. And now, take that 25 out of the square root, so I get 5 root 5. Now, of course, I used my calculator to check that that was right. And also, if you use your calculator and you realize it's 5 root 5, then you can probably figure out it's going to be 25 times 5 under the square root there. Let's do the same with the square root of 80, shall we? Now, the square root of 80, well, if I put that in my calculator, I get 4 root 5. So I know that it's going to be the square root of 16 times 5. And now you can take that 16 out, square root it, gives you 4 root 5, just like my calculator said. So now let's look at this fraction here. I've got root 125, which is equal to 5 root 5, plus square root of 80, which is equal to 4 root 5, all over root 3. Well, at the top of there, 5 root 5 plus 4 root 5 is 9 root 5. That's all over the square root of 3. Looking good so far. But I need to express this in the form the square root of n, where n is an integer. So I haven't managed that yet. But I am going to now rationalize the denominator of this fraction. So I'm going to multiply top and bottom by root 3, because that will get rid of that square root on the bottom. Root 3 times root 3 is 3, and 9 times root 5 times root 3 is 9 times the square root of 5 3s are 15. Look at that. Now I can divide top and bottom by 3. So that gives me 9 root 15 divided by 3 is 3 root 15. Have I done it now? Express this fraction in the form the square root of n. Well, it's not quite the square root of n yet, is it? At the moment, it's still 3 root 15. That's not just the square root of something. I'm going to need to put that 3 back under the square root. So that's going to be the square root of 9 times 15, which is the square root of 135. And now I have expressed this fraction here, this blue fraction, as the square root of an integer n. And that is question 15 complete. Question 16, expand and simplify these 3 brackets. Right, this is just an exercise in not messing up your algebra. Let's start by expanding and simplifying those 2 brackets at the end, those yellow brackets. So I'm going to copy down 2x plus 3. Now I'm going to open a square bracket, and now I'm multiplying out x times x times the 4. Well, that's x squared plus 4x, and carry on. Minus 5x minus 20. Now, before I do anything else, I'm going to simplify my square bracket. It's going to be x squared minus an x minus 20. It's always worth showing every stage, because if you do make a small mistake, the examiner will be able to see where you've made that mistake and will give you all the credit they can. Now, this is 2x plus 3, lots of the square bracket. So it's going to be 2x times everything in the square bracket, and then 3 times everything in the square bracket. So I'll do those in different colours just so it's clear. So 2x times x squared, 2x cubed. 2x times minus x, minus 2x squared. 2x times minus 20, minus 40x. Now, plus 3 times x squared, plus 3x squared, minus 3x, minus 60. And now I have to simplify that, tidy it up. Altogether, I've got 2x cubes. That's those ones done. Now the x squared, so look at that. I've got minus 2 and plus 3. So that's going to give me plus an x squared. The x is minus 40x minus 3x minus 43x with minus 60 left at the end. And that's question 16 done. Now, question 17 is a question on bounds. So my suggestion is, before you do anything else, that you work out the upper and the lower bound of each of your variables. So we've got a is 8.3, correct to 2 significant figures. So that could be 8.35 or 8.25. C is equal to 2, correct to 1 significant figure. So that could be 2.5 or 1.5. And y is equal to 15 to the nearest 5. Half 5 is 2.5, so I'm going to go up 2.5 and down 2.5 from the 15. Now, the reason that I do that first is that I just think about the upper and lower bound and not about anything else. Then I'm more likely to get them correct. Secondly, if I do make a small mistake, well, the examiner is going to see where I've made the mistake. So I'll get credit for all my correct thinking later on in the question. Now, I'll read the question now. It says, calculate the upper bound for the value of p. So I want the upper bound for p. So let's see, p is a multiplied by something, isn't it? So if I want this to be as high as possible, I'm going to want the highest a, and I'm going to want c plus y to be as high as possible as well. So that means that I'm going to want the highest c and the highest y. So in this case, in fact, you want the highest possible value of everything, the upper bounds, which makes a change because normally they mix it up. Right, the upper bound of a. By the way, why have I concentrated on this? Because then I've done my thinking about the bounds before anything else, or on its own. So I can concentrate on that. I'm more likely to get it right. And also, if I make a small mistake, the examiner can see where that mistake is, and I get all the credit I deserve. So now I fill in the upper bound of a, 8.35, multiplied by 2.5 plus 17.5. Now it's just a question of using my calculator and putting that in. It's going to be 8.35 times, you do that bracket first, but the calculator would do that for you anyway, times 20, which gives you an answer of 167. And that is the upper bound for the value of p. Question 18. A particle is moving along a straight line that passes through a fixed point O. The displacement, s meters, at a time of t is given by this formula. Find the value of t when the acceleration of the particle is 5 meters per second squared. Now, did you know that if you have a formula for the displacement, then the first differential gives you, that would be ds by dt, of course, gives you a formula for the velocity of that particle. If you didn't, then just learn it. So I'm going to do that now. 2 times 2t cubed differentiated 3 times the 2 is 6, and now I'm only going to have t squared. Minus 2 times 5 is 10, and now I've only got t to the 1, plus, that's a 1 there, isn't it? 1 times 6 is 6. T to the 0, just leave it. Okay, did you know that if you have a formula for the velocity, then you can differentiate that, dv by dt, to get a formula for the acceleration? If you didn't, then just learn that that's what happens. Start with displacement, differentiate it, get velocity, differentiate that, get a formula for acceleration. So now I'm differentiating this. 2 times 6, 12, t to the 1, minus 10. So that's a formula for the acceleration of the particle. So now I've got 3 formulas. I've got the formula for the displacement at the top, a formula for its velocity in the middle, and a formula for its acceleration at the bottom. Find the value of t when the acceleration of the particle is 5. Oh, well, all I need to do is to find what value of t makes the acceleration, which is that, equal 5. So I just have to solve this equation. Let's add 10 to both sides. 12t equals 15. Divide both sides by 12, and t is 1.25. So the particle has an acceleration of 5 meters per second squared after 1¼ seconds. Question 19. Right, functions. I've got 2 functions there, the function f and the function g. State which value of x cannot be included in any domain of g. Well, you're not going to be able to work out a value for the function of x. You're not going to be able to use this function if you're dividing by 0. So if 2x minus 9 equals 0, then you're not going to be able to calculate g of x. So what value of x would make 2x minus 9 equals 0? Answer when x is 4.5. So if x is 4.5, you'll end up dividing by 0 there, and you won't be able to calculate an answer. So the answer is the value of x, which must be excluded, is x equals 4.5. Find f of g of 4. So I'm going to g4 first. Now if I G4, then I get 5 divided by 2 fours are 8, minus 9. So I get 5 divided by minus 1, which is minus 5. So now I'm going to take the value of G of 4. Here I'm going to take the value of G of 4, which is minus 5, and F that. So now I'm going to F minus 5. So that's going to be 5 times minus 5 plus 7, which is minus 25 plus 7, which is minus 18. So FG of 4 is minus 18. Right, the function h is such that, and written there, the function h, where x is greater than 2. We're going to need that later. Express the inverse function in the form. Right, so I've got, I always do this the same way. If you want a hand with these and you want more to practice, then leave me a comment and I will give you a link to a film of lots of practice of these. Now I'm writing y equals h of x, and now I'm going to make x the subject of that. Now how do I make x the subject of an expression like that? Answer, you complete the square. So now, again, if you want practice completing the square, just let me know and I'll give you a film to work through. When I complete the square here, I'm going to take out a 3 from here first, because then I'll be dealing with a unitary x squared. So 3 minus 4x, close the bracket, copy down the plus 8. And now I'm simply going to complete the square on that bit there. So I'm going to have 3, open a square bracket, x minus 2 squared minus 4. Now, if you're not sure what's going on, you need to practice these until you can do them without thinking. So leave me a message, leave me a comment, and I'll help you out. Minus 12, I've just multiplied out the square bracket, copy down the plus 8. So I get 3 lots of x minus 2 squared minus 4. Y equals 3 lots of x minus 2 squared minus 4. Now, what do I do next? Okay, well, I'm going to make x the subject now. So I'm going to add 4 to both sides. So I've got y plus 4 equals 3 lots of x minus 2 squared. Now let's divide both sides by 3. X minus 2 squared. Now I'm going to square root both sides. Now remember, there are 2 answers to a square root. So it's going to be plus or minus y plus 4 over 3. That's going to equal x minus 2. So now, if I just turn it around, then you can see it more clearly. X minus 2 equals plus or minus the square root of y plus 4 over 3. Now I'm going to add 2 to both sides. So x is going to be 2 plus or minus the square root of y plus 4 over 3. So now I've been in a position to write down the inverse function. And what I'm going to do is I'm simply going to write down the right-hand side, but I'm going to substitute an x in here. So the inverse function, okay, which it wants me to write in this form, is 2 plus or minus the square root of x plus 4, my mistake. But I haven't quite finished. Why haven't I quite finished? I haven't quite finished because here it told me that x had to be greater than 2. So it can't be 2 minus anything. So the only possible answer is 2 plus that square root. You can't have 2 minus that square root because that would give you an answer for x of less than 2, and x has to be greater than 2. So that's quite a hard one, 4 marks there, and that is question 19 finished. Question 20. Now, there are many different ways of tackling this question, so if you've got a different way, please do tell me in the comments. Now, this is the way that I have done it. Right, we've got an equilateral triangle here. It's got sides of 10 as marked. It's got a circle drawn inside. Okay, and you're asked to find the total area of the shaded region. So essentially, I'm going to find the area of the whole triangle, the area of the whole triangle ABC, And then I'm going to find the radius of the circle and then the area of the circle and subtract that area of the circle away from the whole triangle. Let's start off by finding the area of the whole triangle. So to find the area of the whole triangle, so the area of the triangle ABC, I'm going to use the sine area formula. The area will be a half. Now, if I imagine these two sides there and the angle in the middle, it's an equilateral triangle, so that angle's 60, isn't it? So I'm going to have a half times 10 times 10 times sine 60. So that gives me the area of the whole triangle, which works out at 25 times root 3 on my calculator. There you go, I found the area of the whole triangle. Now I really need to find the area of the circle, and to do that, it would really help if I knew the radius of the circle. Now let's have a look. If I were to draw this line here, okay, now that line cuts AB in half. So it will cut this angle in half. Now that whole angle is 60. So this angle here will be 30. Now, how's that going to help me find the radius, you ask? Well, here's the center of the circle. And if I draw a vertical line here, then we know that CB, which is this line, is a tangent to the circle. So we know that this is a right angle. And what's more, I know the length of CE is 5 because it's half the whole length. So what I've got in red there is I've got a neat little right angle triangle there. It's got an angle of 30, an adjacent of 5, and if I can find the opposite, then I'll be able to find R, won't I? So I'm going to use tan, and I'm finding the opposite. R will be tan 30 multiplied by the adjacent 5. So stick that in my calculator, and now I know the radius is 5 root 3 over 3. So that means that I know the area of the circle now. So the area of the circle will be pi r squared, won't it? So it's going to be pi times 5 root 3 over 3 squared. So that means that I can find the area of those shaded regions, because the area of the shaded regions is going to be the area of the whole triangle, 25 root 3, minus the area of the circle. Now, as I say, I'm quite sure there are other ways of doing it, so please do tell me what your method was in the comments. To 3 significant figures, I get 17.1 square centimeters. And that is my solution to question 20. Question 21. A line with that equation, I'll underline that in green, intersects the curve with this equation at points A and B, or at 2 points. Find the coordinates of A and the coordinates of B. It just wants me to solve these 2 equations simultaneously. So let's write down the first one and the second one and have a look. Solving simultaneous equations when one is quadratic. Well, generally, we use one of the equations to get an expression for x or for y, and substitute that expression into the second equation. This top equation gives me an expression for x quite easily, just by minusing 2y from both sides. So now I'm going to substitute that expression for x into my second equation. So my second equation, instead of being x squared, it's going to be 5 minus 2y squared. Let's write that out properly. 5 minus 2y times 5 minus 2y, then plus 3y squared equals 13. Now here's an equation which has just got y's in it, so I can solve that for y. I just need to not mess up the algebra. Right, I'm going to multiply out, first of all, 5 times the second bracket. So that's going to give me 25, 5 times 5, 5 times minus 2y, minus 10y. Now I'm going to do minus 2y multiply by that second bracket. Minus 2y times 5, minus 10y, minus 2y times minus 2y plus 4y squared. Copy down the plus 3y squared, copy down the equals, copy down the 13. Let's tidy up the left-hand side. 7y squared. Now what about the y's? Minus 20y, and then plus 25 equals 13. Okay, let's subtract 13 from both sides. 7y squared minus 20y plus 12 equals 0. Now, I've got to solve this quadratic equation. We could look to factorise it, and perhaps it will factorise, but I'm just going to use the formula. And remember, the formula is given to you at the top on the formula sheet. In this case, it's y equals, not x equals. Y will be minus b, so that's 20, plus or minus the square root of b squared, minus 20 squared, make sure to put that in a bracket, minus 4 times 7 times 12, square root of all of that, all over 2a is 14. So now I just put that in my calculator twice, or put it in the calculator once, press equals, and then change it so that you have got then 20 minus rather than 20 plus, and get your two answers for y. I get y as 6/7 or 2. Now, each of those values for y, that's the y coordinates, by the way, of point A and point B, but each of those values of y have a corresponding x coordinate, then they have a corresponding value of x. So if y is 6/7, then remember up here, remember x is equal to 5 minus twice y. Well then, if that y is 6/7, then it'll be 5 minus twice 6/7. Stick that in your calculator, and you'll get x is 3 2/7. So that's one of my points. X is 3 2/7, and y is 6/7. So that's one of the points of intersection. Now the second point of intersection, well, that's going to happen when y is 2, and x is 5 minus twice y, which is going to be 5 minus 2 times 2, which is going to be 1. So that is the point 1, 2. X is 1 and y is 2. And there are the coordinates of the 2 points where the curve and the line intersect. And that's number 21 done. Question 22. Now, these vector questions are very common and they are a must if you're going for a top grade. So if you'd like a hand with these, leave me a comment and I'll send you the link to a playlist which contains lots of these questions walked through for you to practice. Right, let's have a look at this one. First thing to do, make sure that all the information you're given is written onto the diagram, and indeed it is. Now find the vector OC in terms of A and B. Right, so I'm going from O to C. Now that's going to be OC. Now I tend to do these very slowly and carefully because there's no way I'm going to make a mistake. So to go from O to C, I'm going to go O to B and then B to C. So I'm going to write equals AB plus B to C. So that's 4B plus 2A minus 2B. And so if I simplify my answer, as I'm asked to do, I get 2B plus 2A. And that is the vector OC. Next, find the vector AB. Let's have a look. If I'm going to go from A to B, well, I'm going to go from A to O, and then from O to B. So for me, AB is going to be A to O plus O to B, which is now A to O. O to A is 3A, so A to O is minus 3A plus 4B. So I'm going to write that as 4B minus 3A, not that it matters which way round you write it. So that is part A of question 22. Right, part B. Now part B asks me to find the ratio using a vector method AP to PB. Now I'm going to do that up here so I can have the diagram handy. If you were doing this on paper, presumably the page you're now working on would be opposite the page with the diagram. So here's my part B. I'm going to do it here, and I'm finding the ratio AP to PB. Now there's a set way of doing these. As I say, if you want some practice, leave me a comment and I'll give you a link or two. Now, I'm going to find two different ways to go from O to P. So I'm going to do OP in a blue route and OP in a red route. Now my OP in a blue route is going to use the line AB. So I'm going to go up here and down to there. And my red route is going to use the other route that goes through P. It's going to go here, just O straight to P. So one of my routes is using this line that goes through P, and the other one is using that line that goes through P. Right, the blue route. OP this way is going to equal O to A plus A to P. Now I know O to A is 3A. Now A to P, well, A to P is a certain fraction of A to B. It's a certain fraction of that whole movement. I don't know what fraction that is, so I'm just going to call it x of A to B. And in the same way, O to P in my red route is just a certain fraction of OC. And I don't know what fraction, so I'm going to call it y of O to C. Now, conveniently enough, if I go back to my blue route, I've got 3a plus xab, and you've already worked out a to b, so that's x of 4b minus 3a. I've just copied that from this answer here. And similarly, in the red route, I've already worked out OC. O to C is 2b plus 2a. I've just copied that from there. Back to my blue route. 3a plus, multiply out the bracket, 4xb minus 3xa. Now I know in a moment I'm going to need to have all my a's together. So I'm going to write this as 3a minus 3xa and then plus 4xb. Now let's go to the red route. Multiply out the bracket, 2yb plus 2ya. Okay, now, next stage. You see how we've got an expression for OP here in blue, and we've got an expression for OP in red. Now the blue expression and the red expression are both expressions for the same movement, the movement from O to P. So they must both be equal. Now if the blue and the red are both equal, they must both have the same number of A's in them and the same number of B's. Let's have a look at this blue. How many A's has it got? Well, to work that out, I'm just going to pull A out, and now I can see that it's got 3 minus 3x A's. And how many B's has it got? 4x B's. And what about the red route? How many A's and B's has it got? Well, it's got 2 YA's, look, and bizarrely, it's also got 2 YB's. Back to the blue. How many A's did the blue have? Ah, that many A's. Oh, wait a minute. Oh, and sorry, this many B's. So the number of A's in each of the routes must be the same, and the number of B's in each of the routes must be the same. So the number of A's in the blue route, 3 minus 3x, must equal the number of A's in the red route, 2y. And the number of B's in the blue route, 4x, must equal the number of B's in the red route, 2y. Look at that. I've got two equations in x and y, so I can solve them simultaneously. Now, there are lots of different ways of solving these two equations simultaneously, and it always depends on what they look like at the time. In this case, I've got something equals 2y and something else equals 2y. So I'm just going to write that the something must be the same as the something else. Now I'll add 3x to both sides. 3 equals 7x. X equals 3 over 7. And for good measure, I'll just find out what y is. Well, 2y is equal to 4x. So 2y must be equal to 4 times 3 sevenths, 12 sevenths. So 1y must be equal to 6 sevenths. Okay, good. Back to the question. Now the question asks me to find the ratio AP to BP. That is here, look. AP to BP. Well, I've said that AP is equal to an x of AB. So AP, which is this blue line here, is equal to an x, 3 sevenths of the whole line. So if I were to draw that out here to really try and make it clear, I've got A down to P down to B. And AP, this bit, is 3 sevenths of the whole thing. So this bit must be 3 sevenths of the whole thing. Well, we've said that. So this bit must be 4 sevenths of the whole thing. So the ratio of AP to PB must be 3 to 4. So my answer is that AP to PB is equal to the ratio 3 to 4. And that is my solution complete for question 22. As I say, if you want some practice and some how-to films, leave me a comment and I'll send you a link or two. That's question 22 done. Question 23. Here is a frustum of a cone. A frustum is made by removing a small cone from a similar large cone. Note that word similar. The height of the large cone is 15, that's marked. The base, let's take them off here so that my ticks don't get in the way. The radius of the base of the large cone is 6, that's marked. The radius of the base of the small cone is x, that's marked. Given that, the volume of the frustum is that. So we're going to need to find an expression, aren't we, for the volume of the frustum. Okay, and then set that equal to this. That, I think, is going to be the secret. So we need to find an expression for the volume of the frustum and set that equal to 4212 over 25 pi. Great. How are we going to find an expression for the volume of the frustum? Well, the volume of the frustum is going to be the volume of the whole cone, subtract the volume of the smaller cone, isn't it? Now, can I find the volume of the larger cone, the volume of the whole cone? I'll say large cone. Well, the formula for the volume of a cone is given to you on the formula sheet, 1/3 pi r squared h. So in this case, it's 1/3 times pi times the radius of the large cone is 6, and the height of the large cone is 15. Bit of calculator action, and you will find that the volume of the large cone is 180 pi. Good. Now, if only I knew the volume of the frustum, the volume of the small cone, the volume of the cone on the top, then I could subtract that away from the volume of the large cone, and I'd be left with the volume of the frustum. Now, let's see if we can't come up with an expression for the volume of the small cone. Right, I'm going to go over here, and I'm going to think about the volume of the small cone. Now, what do I know about the volume of the small cone? Well, I know it's 1/3 pi r squared h. Now, let's have a think about this height of the small cone. The length that I'm thinking about is this length here. Okay, that height. Now, it's going to be a certain fraction of the height of the large, isn't it? Because they're similar shapes, right? So the small cone has got a radius of x compared to a radius of 6. So the ratio of those sides, well, the small cone has a radius which is x over 6 of the large cone. So the small cone's height will be x over 6 of the large cone's height. So the height of my small cone, which I'll call h here, h will be a certain fraction of 15. It'll be x over 6 times 15. And now you've got an expression for h in terms of x. I could simplify that, I suppose. 3 goes in, doesn't it? 5x over 2. So the height of the small cone on the top is 5x over 2. Now the joy of that is that I can now find the volume of the small cone, and I've only got one unknown, x. It's going to be a third times pi times r squared is x, isn't it? So x squared, sorry, r is x, so r squared is x squared, times h. And rather than writing times h, I can write 5x over 2. And now I've got rid of that h, right? So now I've got a third times pi times 5x cubed over 2, which is going to simplify to 5 over 6 pi x cubed. So that is the volume of the small cone. So the volume of my frustum then is going to be the volume of the whole thing, volume of the large cone, minus the volume of the small cone. There's an expression for the volume of the frustum. That should be a 6. I haven't written that very clearly. And that equals 4212 over 25 times pi. Now there's an equation just with x, isn't it? Look, let's divide everything by x. Sorry, divide everything by pi. Get rid of those pi's. 180 minus 5 over 6 x cubed equals 4212 over 25. Let's get the x cubes on their own, shall we? So I'm going to subtract 4212 over 25 from both sides and add 56x cubed. So now on my calculator, I'm going to do 180 minus 4212 over 25, and then I'm going to divide that by 5/6 to leave me with x cubed. Now when I do that on my calculator, I get x cubed is 1728 over 125. So x is the cube root of that. So x is 2.4. And that is my solution for question 23. It all hinged on two things. The first thing, realizing that it tells me the volume of the frustum. So I have to come up with an expression in terms of x for the volume of the frustum. And that gives me that expression equals this, so an equation in x. And the second thing that one had to do was to get rid of this x and put it in terms, get rid of the h, the height of the smaller pyramid, the height of the smaller cone. You had to put that in terms of x, so that then you were just dealing with x's in this equation. And you put that in terms of x because the two cones were similar. Okay, that's question 23 done. Question 24, we're almost there. Now these questions involving algebraic fractions appear a lot, and you need to be very confident with your factorising, difference of two squares, and all of that. So if you'd like a hand with these or you want more practice, leave me a question in the comments or a request in the comments, and I will send you some links to help you out. Now, the first thing I'm going to do here is I'm going to simplify the left-hand side because there's quite a lot going on the left-hand side. Let's start off by simplifying that. 45x cubed minus 80x. Well, let's factorize that. That's going to give me 5x outside the bracket, 9x squared minus 16. Now this happens quite a lot because that's not fully factorized yet, because this is the difference of two squares. So that will factorize to 3x minus 4, lots of 3x plus 4. If you didn't spot that, you need some practice. Leave me a comment, I'll send you some links. That's the top there. Now, let's now have a look at this. That factorizes 3x squared plus x minus 4. It's going to factorize into two brackets. It's got to be 3x and x, hasn't it? Okay, now one's got to be a plus, one's got to be a minus. We've got to end up with 1x at the end. So a bit of fiddling gives me this. Let's just check I've got it right. It's going to give me plus 4x's minus 3x's does give me plus 1x. And it gives me minus 4 at the end. Good. So now this fraction has just become easier. Okay, so what is it going to become? Well, it's just become 5x lots of 3x minus 4, 3x plus 4, all over 3x plus 4 and x minus 1. I can see some cancelling there already, times by. Now, what's going to happen here? I'm adding algebraic fractions. So let's put them in a bracket here so we don't mess it up. I'm going to write them both as over the common denominator. Now the common denominator is, I'm going to multiply both of those denominators together. So my common denominator is x lots of 3x minus 4. And then I'm going to multiply the 1 by the x. And then at least it's a plus here rather than a minus. Normally it's a minus. And then I'm going to multiply up there as well. So I'm going to have plus 1 lot of 3x minus 4. Of course, had that been a minus, which it often is, I'd need to be careful here and put that in a bracket. But it's not a minus, so that's okay. Right, getting there now. Well, slowly. So, look at this. I can cancel here. 3x plus 4, divide top and bottom by 3x plus 4. It's made life a bit easier, hasn't it? Now, what's going to happen here? So I'm going to have 5x lots of 3x minus 4 over x minus 1 multiplied by, what have I got on the top here? I've got 3, no I haven't, I've got 4x minus 4 on the top, haven't I? And 3x squared, well I'm going to leave it factorised actually. The reason I'm leaving it factorised is because I can cancel here and here. Actually, look at this. This 4x, 4x minus 4, that can be written as 4 lots of x minus 1. And so now I can cancel there and there. So now I can multiply top times top, bottom times bottom. Going to be 5x times 4, which is 20x. I've just seen more cancelling, never mind, over x, which boils down to 20. So my left-hand side equals 20. Gosh. Right. So this equation here, which I'm solving for x, boils down to 20 equals 4 lots of x plus 2 over 5x minus 8. Well, it just got a bit easier, didn't it? Multiply both sides by 5x minus 8. 100x minus 160 equals, multiply that bracket, 4x plus 8. Oh, equation with x's on both sides. Subtract 4x from both sides. 96x minus 160 equals 8. Add 160 to both sides. 98x equals 168. Divide both sides by 96. X equals 7 over 4. And there you are. That's that last question done. But what a lot of simplifying I had to do there. I had to be fluent at completing the square, or factorising the difference of two squares, I beg your pardon. I had to be fluent at adding algebraic fractions. I had to be fluent at factorising quadratics. And then I had to be okay with cancelling top and bottom. Right, that's the end of question 24. Hang on for a moment and I'll give you some details about the grade boundaries. Mr. Wright here, and well done for making it through to the end of the paper. In a moment, I'll show you the grade boundaries and I'll show you how to calculate what grade you would have got had you been sitting this paper or this set of papers. But first, if you found these video walkthroughs useful, please do hit like. It really helps the channel and it tells me that you have found the film useful, and it's good to have some positive feedback. Of course, if you want to see more of the same, do subscribe to the channel and then you'll get notifications every time I post something new. So, the grade boundaries. Well, here they are. And what you need to do is to add together your 2 marks on the 2 papers. Of course, both marks out of 100, so that gives you a total out of 200. And then you can use this table to read off what your grade would have been had you sat this set of papers. Leave me a comment, tell me how you've done, and good luck with your exams.